right. I'm going to go forward in some pages. Couple things I want to remind you about. Let's get rid of that. So there was a quiz. There is the opportunity to earn points back. You can actually earn the 61 out of 60. Okay? Regardless of whatever you did on it. You have until Friday on one of your off periods to come do it. Come make it up. Come see me. Doesn't matter if I'm teaching another class or not. You're welcome to be in here. Okay? I already had students that came in last period. One of them got, or a couple of them got some points back, which is great. A couple of them were like, we're not ready for this. So I was like, that's fine. So they're going to go kind of study a little bit more. But come Friday, end of Friday, 8th period Friday, that's the last day to do it. And friends, remember, the conversation that goes home might not be the conversation you necessarily want to have when parent or guardian is sending me an email saying, what can my kid what can my kid do better in your class? And I say, well, they had the opportunity to get all their points back as well as use that sheet, that review sheet on it, which is cool. I mean, that's a pretty neat gift. So make sure you take care of that. Some of you had missed when we took that test, so I will extend for you, but if you are that student, but not everyone is that student. Okay? So I saw that we were on page 83, 84, right? That was the homework. So which ones could I help you with? Any questions on page 83, 84? Yeah, 2. You got it. All right. So problem number 2, we have this, 2x squared plus 4x minus 3. And I'm going to do the best I can to draw kind of sort of an okay xy axis that we can definitely identify points. Okay. So the first thing we want to do is I want this on every problem. Negative b over 2a. Please just amuse me by always writing it down. Okay? Then I want you to write your a value is 2, your b value is 4, and your c value is negative 3. Okay? Pretty straightforward. Everyone agree? Anyone stuck on any of that? So the negative b over 2a finds us something called the axis of symmetry. That's the line we could fold over. It's a vertical line. It also finds us the x component of the vertex. All right, so if I do negative b over 2a, I get negative, because there's a negative there, b, which is 4, over 2a, which is 2 times 2. So that's negative 4 over 4. And negative 4 over negative 4 is negative 1. So I have an axis of symmetry, we'll call AOS that, of negative 1. So remember, x equals a number is a vertical line. So let's call this our axis of symmetry, negative 1. Seem okay? So we'll call that negative 1, maybe call that negative 2, negative 3, call that 0, 1, 2, 3. And my graph might not look as fancy as yours, but it is what it is. All right. So then the next step you want to do is you want to start finding your vertex. So I know that x equals negative 1. That's the first part of my vertex. How do I find my other part of my vertex? What should I do? How do I get the y part of my vertex? Ooh, too many days off. Yeah. Yeah. Plug the negative 1 in to your x's up above. So I'm going to go 2 times negative 1 plus 4 times negative 1 minus 3. Well, negative 1 quantity squared is 1. 1 times 2 is 2. 4 times negative 1 is negative 4. And then I get minus 3. Then we just have to do the arithmetic. I don't know how my tongue got big on me. All right, so I go 2 minus 4 is negative 2. Negative 4 minus 3 is negative 5. So I find that negative 1 comma negative 5 is my vertex. Agree? And then we could have start filling out our table drawing, but maybe we'll do that below. All right, so now I can pattern graph. So I'm going to pattern graph using A times 135. What's my A value up here? 2. So I have 2 times 135. So my pattern graph is going to be 2, 6, 10. Agree? And it's always the same. So we're going to go from the vertex on the first one. So I'm going to go right 1, up how many? 2. So that appears to be the point negative, or you know what? I was off a little bit. Sorry. I'm going to go right 1, up 2. So that appears to be the point 0, comma, negative 3. And then if I go back to my thing, I'm going to go left 1, and I'm going to go up 2. And so that appears to be the point negative 2, comma, negative 3. Agree so far? Now, for my new blue dots, how far up do I go for my blue dots? How far do I go? 6, all right? So I'm going to go right 1, up 1, 2, 3, 4, 5, 6. So that's going to give me the point 1, comma, 1, 2, 3. And then I'm going to go from this point, I'm going to go left 1, up 6. 1, 2, 3, 5, 6. And again, I didn't have a nice grid, but I know that that's going to be the point negative 3, comma, 3. So this is what my parabola is going to look like. Done. Okay? You can easily fill out your table if they wanted you to do that. You have x comma y. So I make the very middle one the vertex. So the vertex we found was negative 1, negative 5. To the right, I go to 0, negative 3. To the left, I go to negative 2, negative 3. To the right one more time, I get to 1, comma 3. And to the left of the other one, I get to negative 3, comma 3. That's all done. Okay, that's the whole problem. Okay, did we answer the questions? Will your parabola open up or down? Looking at it, looks like it's going up. Use negative b over 2a to find the vertex. Got it. Give the equation of the axis of symmetry. We got it. Complete the table. Got it with the vertex centered. Sketch the graph. Got it. We answered all the questions on it. Okay. What else do you see? 3. Turn the page. All right, number 3. I'm going to come sit over here. Not because anyone did anything wrong over here. It's just I feel like having a different perspective on you guys. All right. So number 3. We have y equals negative x squared plus 4. Okay? All right, so again, I'm going to try and draw myself an xy axis that is somewhat presentable. Realize mine doesn't have from negative 10 to positive 10, so I'm just making up tick marks as we go along. So I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't know, something like that. All right, first thing I want you to write on every problem is, thank you, negative b over 2a. Trust me, my friends, by doing it and repeating it, you're going to have it always right. Okay? My a value is what? What's attached to x squared? Negative 1. Right? B value. Is there a number with an x? I don't see any x up there. I see x squared, but I don't see x. So what does b have to equal? 0. And my c value is 4. Okay. Feel pretty good about this so far. So let's do our negative b over 2a. So I'm going to get negative 0 over 2 times negative 1. Well, this means x equals 0. That's my axis of symmetry. X equals 0 is a vertical line going right up this axis. So what's going to live on that y-axis? Starts with a V, ends with an X, has Vertex in the middle. Vertex, yeah. All right, so I know for my vertex, I have 0, comma something. How can I find the something? Plug it in, plug that 0 in. So I'm going to get negative 0 squared. Hey, what's negative 0 squared? 0. So I get 0 plus 4, 0 plus 4. So 0, comma 4, 1, 2, 3, 4. There's my vertex. So 0, comma 4. Okay, my pattern graph is going to be A times 135. Agreed? What's my A value? Negative 1. So what is that going to do to our parabola? Opens down. Very good. Okay, so my pattern graph is simply done this way. So I'm going to go from this point, I'm going to go right 1, down 1. So that takes me to the point 1, comma 3. I'm going to go left 1 from my vertex, down 1. So that takes me to the point negative 1, comma 3. And then we'll find another one. So I'm going to go from those new dots, I'm going to go right 1, down 3. So right 1, down 3. I'm going to go left 1, down 3. So this gives me the point 2, comma 0, and this gives me the point negative 2, comma 0. Okay, we have enough there to graph our parabola. So one thing I wanted to know, what is very special about these 2 points? What are they known as? Starts with an R, ends with an S, has oot in the middle. Roots. Okay, so this is a root, and this is a root. So if I wanted to complete my table, I wanted to do my parabola table. What am I going to put in the very middle? 0, 4. To the right, 1, 3. To the left, negative 1, 3. To the right of this one, I get to 2, 0. To the left, I get to negative 2, 0. Okay. Will the parabola open up or down? I think it's pretty obvious. Down. Use negative b over 2a to find the coordinates of the vertex. We have it. Give the equation the axis of symmetry. Got it. Complete the table. Got it. Find any roots. Got them. So remember, a lot of times it might cross the x-axis, but I can't see exactly where the roots are because it didn't land right on it. Complete the table. We got it. Sketch the graph. Got it. We have it. We have everything. Okay? So again, friends, that quiz and the test that we took, you have the opportunity to come in by Friday on one of your off periods to improve your score. You can use the review sheet. Go back to the review video. Can't find the review video? Figure it out. It says on a Tuesday like last week, review in the title of the video. Well, I don't know where to find your videos. Then don't worry. We offer this class every year. You can take it again next year. I had a student say, I can't find anything on Schoology. Okay, well, then I'll just pass you. It's not middle school. We don't just pass you. So, yeah, you do. No, we don't. My mom's going to get mad at me because I did all my work. I got video documentation of it. Yeah, you're not teaching me that well. Okay, have your mom watch the video and tell me what I can improve on. She didn't have time. Well, don't criticize me then. Honestly, conversations I've had. It's kind of sad though. All right, so friends, I am on page 85 in the notes. Okay. Okay, ready? Couple of things I'm going to squeeze in here. For the x values, I'm going to call x values from here on out the domain. For our y values, I'm going to call the range. Now, Sometimes it gets hard to remember. Domain goes with what? X, Y are alphabetical. You still following me in that? Domain and range are alphabetical as well. So X comes before Y, D comes before R. So it stays alphabetical. So that's kind of a nice little thing to deal with. I'm going to put a V in the middle right here. What's that V going to represent? Vertex. Okay. Again, my X is going to be, I'm going to start referring to more and more as the domain. The Y value I'm going to start referring to more and more as the range. Hello. It looks like you have a Valentine. Nah? Got it. Is he good? All right. Perfect. Thanks. All right. So what's the first thing I want you to put? Graphing. What's the first thing? Negative b over 2a. And I know it sounds like, oh, we do it every time. Yeah, but you're repeating it. You're getting it. Okay, what's my a value up above? 1. B value? C value? Negative 8. So notice we kind of got away a little bit from graphing the y-intercept. Got away from it because it's not always an important point. But, I mean, we could plot it if we wanted to. Maybe it'll find up on pattern graphing. Negative b over 2a, so I'm going to get negative b. My b value is 2 over 2 times my a value. My a value is 1. So I get negative 2 over 2. Negative 2 over 2 is what? Negative 1. So x equals negative 1. X equals a number is our axis of symmetry. What lives on the axis of symmetry? Vertex. Okay, vertex lives on there. Gotcha. Friends, what should I do to get the rest of my vertex? Being I know that I have negative 1 comma something. Do what? Plug it in? Yeah. So I'm going to get negative 1 squared plus 2 times negative 1 minus 8. What's negative 1 squared? Negative 1 times negative 1? Positive 1. Good. 2 times negative 1 is negative 2 minus 8. Do the arithmetic. 1 subtract 2. Negative 1. Negative 1 minus 8. Negative 9. So there's my vertex. So negative 1, negative 9 is down here. Put that dot right there. All right. Do we feel comfortable? Pattern graph is going to be a times what? 135. What's my a value? 1 being my a value is 1. Does the parabola open up or down? Up. Good. So 135 is my pattern graph. So for my vertex, I'm going to go right 1, up 1. So that looks to be the point 0, negative 8. So we'll go 0, negative 8. To the left, I'm going to go left 1, up 1. So that appears to be the point negative 2, comma negative 8. So I'll go over here. And then I'm going to go right 1, up how many? 3. So my new points, right 1, up 3. Put a dot. So that appears to be the point 1, comma negative 5. Or positive 1, negative 5. I'm going to go for my blue dot, left 1 up, 1, 2, 3. So that appears to be the point negative 3, comma negative 5. Did you get all done, Joey? Yeah. Cool. That open binder right there, just put it right on top of that, please. Okay, we have plenty of information to graph the rest of this. Here's one thing that we might want to think about. If I went out one more from my black dots, I would go up how many? If I went out one more from my dots, how much would I go up? 7. So I did the 1, I did the 3, now I need the 5. Ready? Right 1, up 5. What did the pattern graph just find here? What is that value known as? Root. So sometimes, my friends, my pattern graphing, 1, 2, 3, 4, negative 4, comma 0. Sometimes my pattern graphing will indeed find us roots. It's not going to happen every time, but if it does, and your pattern graph, you have room for your pattern graph, go a little bit further. The reason I only normally use 1 and 3 is because sometimes I'm going to go off my graph. So that's my parabola. Okay, so now let's talk about this graph. So I want to talk about something that we're going to call the domain here. Domain referred to which value? X. Okay, now let's think about this. Can I go forever that way in the X direction and my graph would still happen? It's going to be way high up. What about if I went forever this way? Is the graph going to keep going up? Sure. So my domain is going to go from negative to positive infinity. Meaning I could plug any value in. Now, if you plug 10,000 in for X, you're getting a huge Y value. It doesn't make sense, but it makes sense to understand that the domain is there any restrictions? Now, as far as our parabolas go, no. Our parabolas will have a domain of negative to positive infinity, whether they open up or down. Our range changes a little bit. Our range is which value? Y. Okay, the range is the Y. So what does it appear to have my lowest Y value? Look at my ordered pairs. What's my smallest Y value? -9. Do I include that as a point? Okay, so my range is going to go from hard bracket or a square bracket, -9. Is it going to open upward? Is it going to keep growing higher and higher and higher in the vertical direction? I believe so. So that's my range. So that's a little different. This is called a hard bracket. Hard bracket means you include the point. Okay? All right. So a few other things about this graph. Looking at the graph opens up. If it opens up, you have a minimum value. You have a minimum value. What is my lowest Y value on this graph? Can be the same thing as our range. What's our smallest Y value? It's our smallest Y value. -9. So we have a min at -9. Our lowest Y value point, -9. Okay, where does that happen at? -1, -9. But -9 is my minimum value. Okay, we do have roots. Our pattern graph gave us the roots. Just because my parabola crosses the x-axis doesn't mean I can always identify exactly what the roots are. But I can tell you every time you have a root, your Y value will be 0. Okay? All right, so this next one, domain, set of all x values. So from our graph on the previous page, or what you had above, domain, negative to positive infinity. What did I say the range was? From the previous page? To infinity. Soft bracket at the infinity. What kind of bracket at the -9? Hard bracket. The reason it's hard bracket is I include that point. Did I have a max or a min value on the last graph? Okay, so what I'll do is if I have a parabola like this, we will have a min. If I have a parabola like this, I will have a max. So on my last graph, my min was -9. The roots are where it crosses the x-axis. So they are points. Okay? So on our last graph, our roots were -4, 0, and 2, 0. And again, if you were looking at points, how can you guarantee your points are a root? What has to happen? Cross x-axis, but if I just gave you a point. If I gave you the point 7, 0, how would you know that would be a root? A little deeper thinking on that. 0 in what spot? You're absolutely right. The y. If the y is a 0, you're dealing with a root. Okay, the vertex just basically comes from -b over 2a, and then plug in for y, or for the x value. Okay, axis of symmetry is always, the vertex will always live on it. The axis of symmetry is always this, negative b over 2a. Okay, so let me just pause. We are going to hit a term that is brand new. We've actually hit a couple brand new ones. Okay. Interval where we are increasing. An interval where we're increasing. So this is going to involve the vertex. The vertex is a turning point. So let me go back to my last graph. Okay. I'm going to highlight. I'm going down, 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 down. Stop there. I'm going up, 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 up. Up means increasing. So that green portion of our graph is where this, where the graph is increasing. So where in the x direction does it start increasing? Positive what? Talk about in my x direction. What x value does my graph stop from going down to going up? -1. Excellent. So the vertex is our turning point. Okay, so where is this increasing? It is increasing from, what was our vertex? -1. So it's increasing from soft bracket -1 to infinity. So it's continuing to go to the upper right. Okay, now, why do you think -1 has a soft bracket, whereas our range up above, which I realize is a different number, our range up above had a square bracket. Square bracket means I include the point. Rounded bracket means I don't include the point. So that -1 is the turning point. Right exactly at that instant, it goes from going down to going up. But there's a moment in there where it's not increasing or decreasing. It's actually just kind of laying flat. Okay? And that's something you'll talk more about in calculus, but we'll still be dealing with it. The value where our f at x is positive. So this means it's above the x-axis. So we're using our x values to talk about this. So if we go back to my graph, this region right here is above our x-axis. This region right here is above our x-axis. That means it's positive. It's above the x-axis. So I have a root there. That root happens at -4, 0. I have a root here at 2, 0. And this is definitely different thinking. It's going to go from -infinity to -4, soft bracket, and then from 2 to infinity. This is very much different math than you've seen. This actually has some calculus concepts to it. The increasing, decreasing, the positive, those are calculus types of terms. Why are you learning this here? Because we want to build you towards calculus. Okay? How are we doing on time? What time are we out of here? Yay. Got plenty of time. Okay. These things right now should be making your brain going, what? What? All right. So this next one on your page, I said the domain of all of our parabolas we will deal with will be what? Negative to positive infinity. The domain goes this way, this way. The domain are the x values. The range, it's opening up, so I'm going to have a square bracket to infinity. What number are we going to fit in right there? What's my lowest y value on this graph? What is that value right there on this graph? What is the y value right there? 1. So it's a hard bracket at 1 because I include that point. That's very different. Does this parabola have a maximum or a minimum value? Minimum. What is my minimum value? We're going to refer to the y on that. 1. Okay. Do I have any roots? Will it be crossing our x-axis at all? Okay. So we're not crossing the x-axis, so we don't have any. So we can just put, oops, I don't want to have dot that. I'm going to just say none, because it's not crossing x-axis. Okay. The vertex, okay, finally something we remember. Vertex is what point? It's red. What point is that? Go backwards. The x first. So 3, 1. Okay. What does my axis of symmetry have to be? What does my axis of symmetry look like? Axis of symmetry is always what value of the vertex? It is that, but if I know the vertex, which value of the vertex is it? X. So my axis of symmetry is x equals 3. Why did it go dotted? I didn't want dotted. X equals 3. Okay, so the x component of the vertex is always the axis of symmetry as x equals. Decreasing, this is where my graph's decreasing. So it's decreasing from negative infinity in the x direction all the way up to 3, soft bracket, because right at 3 it's not increasing or decreasing. And then where is the interval negative? Below the x-axis. Is it below the x-axis at all? Nope. Does not exist. Okay, that graph did not go underneath the x-axis. Whew! Man, this is... Dude, I got to take a nap. Right? Yes. All right. So, we are going to look at page... I know there's one more thing, but we'll do it tomorrow. 87, 88. Will you do me a favor? Will you try problem 1 and 2? And it's actually just on page 87. Okay? It's a lot of new material, so you might have to refer back to your notes, which is in this book. Might have to go back to the video and watch the video. Okay? But that's some very new stuff. So you're doing problem 1 and 2. It's just on page 87. We'll get more of that later. But give it a try. It's okay if it's like, this is hurting my head, because they're new terms. It's healthy for you.